All right, folks. Hey, how we doing? Third period. You guys haven't had to do this too much. I feel like fifth and seventh or fifth and eighth have had to do this a lot, but here we are. So we are learning 10.4. It is the last news section before we take a quiz. Let's take a look at it. So we're talking about inscribed angles today. Something different than a central angle. So it's all today. There's like 4 or 5 theorems we got to go through. Learn about inscribed angles, do some algebra. Shouldn't be super crazy. But thanks for joining me along for the ride here. When I get back, we'll have a review day, and then we'll take a quiz, and then we're going to learn one more thing, and then we'll start reviewing for the final. So we are very close to the end here. Thanks for hanging in there with me. It's been a fun year. Let's get to it. Inscribed angles. What is it? So this is 10.4. An inscribed angle has a vertex on the circle. Okay, so now remember a central angle had the vertex in the center. Now we're on the edge of the circle, and the sides of the angles are chords. Central angle is radii, now they're chords. Okay, so it looks like this. We got angle SRQ, and that is an inscribed angle there. I've said this to fifth and eighth period a million times. But if I'm going too fast, it's a video, so just pause it, write it down, takes a few notes. And I'm going to keep it moving so this isn't too long. So there's 3 ways this inscribed angle could look. Okay, you could have like the example I just gave you, which is case 2, okay, where it's just, it's going through the middle of the circle. You could also have one where one of your chords is a diameter here, okay, and it goes through the center. Case 2, the center is in between the angle. And then you could have case 3 where the center is on the exterior of the inscribed angle. Okay. So those are your 3 options of how these inscribed angles could look. They can mean different things, but really they all kind of follow the same theorems. But those are your 3 visuals there for you. Here, let's jump into our first theorem. We'll do some algebra, learn another theorem, do more algebra. You know the drill. You love the drill. All right, this is so important. This is why we're learning inscribed angles, and you're going to keep using this idea throughout the other theorems. If an angle is inscribed in a circle, then the measure of the angle is equal to 1/2 the measure of its intercepted arc. Okay? So you're going to take, let's say, for example, your arc, the arc length of AB in degrees. Remember, we're not in arc length, arc measure. Sorry, arc measure. Whoa, why didn't you stop? Why didn't you stop this? Let's try it again. So this arc measure, why is this being so weird? This arc measure here, let's say that this is, what do you think that is? 110? Say that's 110 degrees. Your inscribed angle, remember central angle was equal, right? If there was a central angle here, we can draw that in. If there was a central angle here, remember this would also be 110, right? Like we did earlier in this chapter. That would be 110, but your inscribed is half that. Okay, so this is 55. Okay, so that's how inscribed angles work. I mean, that should almost be the definition along with the definition. That's just how they work, even though it's a theorem. All right, and then also if you're given the inscribed, let's make another real quick one. That's a terrible circle. Let's make an inscribed. Let's say that this one is 60. Oh my gosh, this is a travesty, folks. Let's say this is 60. Then your arc is going to be double. It's going to be 120. So you're just going to have to go back and forth, but you can go either way, knowing either one. Okay, so it's either going to double it if you have the inscribed, the arc is double, or if you have the arc, take it in half, gives you the inscribed. Let's skip that. Cool. Let's do a problem. Now my thing came back. So weird. Let's find angle P, and then we'll find measure of arc PO. Okay, angle P is here. Sometimes you might want to kind of like draw on, like, so you can see it. Sometimes it's a little hard to see what arc it's connecting to. But it's connecting to this arc, angle P. This arc is 70, so that means angle P is 35. Okay, it's just half. It's that simple. But sometimes it's hard to see exactly what arc it's intercepting. Okay, so sometimes you might need to redraw it and kind of take a look-see-loo, right? Okay, let's look at the other one. Now we want arc PO here. We want this arc PO. Well, you take your inscribed angle and you double it. So this is going to be 112. It's just 56 times 2. Okay, so that is that. Good stuff. Okay, good stuff. Cool. All right. Let's see if we got those right. Oh my gosh, we're so good. We're so good. Again, be a little careful. So like down here, there's a lot going on here. So it's really like, which one's the inscribed? So down here, they're asking for the measure of CF. Well, CF's here. So our inscribed angle is going to be these guys. Okay, so we're coming from the 40. So you double the 40 and we get 80. Sometimes it's a little hard to see, but the math itself isn't that hard. Angle C. Again, it doesn't look like you're like, angle C. What the heck? We erase all this garbage. Angle C, the one they're talking about, is right here, and that intercepts this arc, which is DE, arc DE. So it's half a DE. DE is 98, so this is 49. Okay. So that's just how inscribed angles work. It's what you do. It's what you do. So we're going to see some more theorems with those. We'll do a couple more algebra problems. And Bob's your uncle. That's it. Skip. What do we think? Skip. That's what I'm saying. 10-7. If I'm going too fast, pause it. Write this stuff down, kids. 10.7 says if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. Makes a ton of sense. Again, these can look a little confusing, but we have two angles, angle B and angle C. And if you follow the red here, you can see angle B intercepts AD. And then if you follow the blue, you can see angle C intercepts AD as well. So they're intercepting the same arc. So again, let's say this was, let's just say a nice 100. Let's say that was 100. Well, they're both intercepting a 100-degree arc. So both of these are 50. Okay. And so you know that they got to be congruent. That's just kind of how it works. Just kind of how it works. Nice little easy theorem. It's just, again, making sure you can see which angles are going to which arcs. Sometimes it does look a little confusing. Tennis all day today. I was at tennis, so hope you're all doing well. Filming this for you. Should be the last time I miss your class, although we're running low. Brendan's got the count. Ask Brendan how many we got left. We're at like 5 after today, aren't we? Crazy. We're going to do review, quiz, learn something new, review, review. Crazy. All right, let's do it. So again, we got this and we got, look at T. T intercepts SV, like that little pink dotted line, and U intercepts SV. So they intercept the same arc. So that means they got to be congruent, a little congruent symbol here. So we can set those equal, okay? So we say 3x minus 5 equals 2x plus 15. Oh, look at look at this. I'm not in my normal filming spot here, so my mouse, it's on an envelope and it's not working great. Should make some higher quality production, shouldn't I? Subtract the 2x, we get x equals, add the 5, we get 20. X equals 20. They wanted us to find t, so we plug it back in. We get angle T is equal to 60 minus 5. So angle T is 55. And then we could double that if we wanted to find SV, right, down here. Find the arc measure, double that, we get 110. I feel like we've had a lot of 110s, 112s, 50s, 55s. Boom, 110 degrees. Let's go, kids. Let's go. Did we get it? Yeah, and we even did a little bonus getting the 110. So yeah, cool stuff. Cool stuff. A little water break here. Everybody doing okay? Yeah. Avery, you back? You feeling healthy? Kendall was lost without you. Kendall was lost without you. All right. Evelyn, what? Evelyn, you want to read the next theorem because you're excited about it? Cool. This is Evelyn reading this one. Go ahead, Evelyn. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. Remember, last class we talked about if and only ifs a couple of times. They came up. Okay. Shorthand, IFF, if and only if. This means it goes both ways. So if we know FJH is a semicircle, then angle G is 90. Okay. And then if you know angle G is 90, FJH is a semicircle. So you can go either way. If you know this is a right angle, this is a semicircle and this is a 180-degree arc. And if you know this is a semicircle, then this is a right angle. This is the one that can kind of trip people up a little bit. It can kind of be hard to see. How they draw this is they always draw it in your book as a triangle because they want to show you for sure that this is a diameter. So it looks kind of weird, right? But this is the angle, or this is the legs of the angle that we're looking at. You can see it intercepts a diameter, so this has to be 180 here. But it can be a little hard to see that sometimes, just how they always draw that diameter on. Because it looks like your mind is just like, that's just a triangle. But it's going to be a right triangle. Right. See, we got a problem here. Oh, we got another theorem. So exciting. This one's also a little funky, but once you get it down, it's not too bad. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay. So if you ever see a quadrilateral inside a circle, it could be a kite, it could be a rectangle, it could be just a quadrilateral, it could be a parallelogram, any of them. Okay. The opposite angles are going to be supplementary, right? Now, this was true of parallelograms when we did that way back in the day, but it wasn't true of any random thing, but in a circle it is. And it makes a lot of sense. Let me give you an example. Let's say KM, not draw, sorry. Let's say KM, let's call that 200 degrees, okay? Let's call KM 200 degrees. That would mean angle L is half of that, okay? Angle L would have to be 100. Okay, but we went around the circle and we did 200 degrees. So my other side, KM or KLM arc going this way, has to be 360 minus 200, which is 160. Well, the angle that intercepts that arc is angle KNM down here. Then that means it has to be 80. Okay, so you can see the arc measures on the outside are always going to have to add up to 360. So the opposite angles are always going to have to be half of that, which is going to be supplementary. Okay. So that works for L and N. It also works for K and M. So K and M here are also going to add up to 180. Okay. It's pretty useful too. Both of these theorems pretty useful. Again, can be a little hard to see at times. But I think those were our last theorems. So now we just got a couple more examples. I feel like we've cruised through this lesson. Hopefully you've taken some notes and learned something. And I'll see you on Friday. So here's this example, kite. I said kite. I was thinking kite, okay? So we got a kite here, and we want to find everything. We want to find angle A, we want to find angle B, we want to find angle C, we want to find angle D. They gave us angle C, okay? C is 90, okay? Maybe that's the easiest way to start. So we got a quadrilateral inscribed in a circle. Opposite angles have to be supplementary. So angle A and angle C have to add up to 180, but we know angle C is 90. So angle A also has to be 90. This is equal to 90. Angle A equals 90. Yeah, boys. Yeah, boys. Cool. Questions, comments, concerns? Cool. Cool, cool, cool. Okay, now this one's a little bit more interesting. I don't know. Again, these got to be supplementary. We got x and we got 2x minus 30. So we're going to go x plus 2x minus 30. That x was so aggressive. That x was so aggressive. And what does this equal? Stone, what do you got? 180? Yeah, Stone's awake back there. Thank you, Stone. Stone Star, the man. I meant the legend. Okay, so we get 3x equals 210. Oh man, I can't even do an equals. We're falling apart here, kids. We are falling apart. And we get x equals 70. I want us to plug that back in and find angle B. So it's going to be 2 times 70, which is 140, minus 30 gives us 110. All right. Good work, everybody. We got 90. We got 70. Oh, they didn't even plug. Oh, yeah. They didn't plug back one time. Do we need to do another one? I think we got the gist. I think we got the gist. Let's see what else we got. Maybe one more example. Yeah, let's do this one. This one is both of these are great. Great examples, kids. Great examples. Again, this you're like, what the heck? How do I relate 3x plus 1 and 7x minus 1? Again, look at your angle here. Angle Q intercepts a diameter. Okay? Angle Q intercepts a diameter. So angle Q's got to be 90. That's just how it works. This has to be 180 because it's a semicircle. Q is half of that, so Q is 90. So it's a triangle. Now we have a right triangle with two angles. Is it isosceles? We don't know. Maybe, but I don't think so because then these would just be the same thing. So instead of just setting these equal, we don't know that they're equal. We don't know it's isosceles. We don't know it's a 45, 45, 90. But we do know these have to add up to 90. So we can do 3x plus 1 plus 7x minus 1 equals 90. The good old 90. Okay. And then it's just algebra. So we get 10x equals 90. The ones cancel. For those of you keeping track at home. And we get x equals 9. And then you can plug that back in if you're feeling like you want to. Okay. Okay. This one's nice. Love this problem. Love this problem. Love this problem. RS is a diameter. Okay. So that means RTS has to add up to 180. Okay. But we know ST is 48. So we do 180 minus 48 to get RT. So what is that? 132. So RT, the arc measure of RT is 132. And now what were we looking for? Angle S. Angle S is inscribed. It is half of 132. So that's that's 66. No. Why can't I do math? What the heck? 60. I literally can't even think of this. This is insane. It is 66. Tricking myself. Yeah, 66. Okay, cool. Jeez, sorry guys. All right, so we get 66 for angle S. Good work. So there you go. Hopefully this wasn't too long. Sometimes it's hard to know how long I've been talking. There's your examples. There's your feelings. There's your fun. I miss you guys. Hope you're doing well. I'm out at tennis. I'll see you when I get back. Hope you're having a great day.